Imagine a world where no government can control what you see or think online. That world is being built right now as decentralized AI nodes, open weight models, peer-to-peer storage, and censorship circumvention tools make it harder to shut down information with a single switch. By turning AI into something that can run locally, move across distributed networks, and survive outside central platforms, activists, journalists, and open internet communities are trying to make digital sovereignty less about the state and more about the user. But let's be precise. That world is not fully here yet. Governments can still block websites, throttle networks, arrest users, pressure platforms, and cut the internet entirely. Access Now's 2025 shutdown report documents that internet shutdowns are still happening across the world, and its hashtag #KeepItOnProject describes shutdowns as a continuing global tactic of repression. So this is not a story about perfect freedom. It is a story about a changing balance of power. Because for most of the internet age, control worked through central points. Central platforms, central hosting, central cloud infrastructure, central app stores, central moderation systems, central telecom choke points. What is changing now is that AI itself is becoming more distributed. Models can be downloaded, inference can run on laptops and phones, training can be coordinated across decentralized infrastructure. Communication layers can work peer-to-peer. Content can be stored in systems designed to be content-addressed and censorship-resistant. And when all of those pieces start fitting together, governments do not lose power entirely. But they do lose the convenience of controlling speech through a few obvious bottlenecks. That is the real disruption. Tonight, we are going to look at the real systems already pushing in that direction. Not fantasy, not sci-fi. Real tools, real networks, real infrastructure. And by the end, you will see why the next fight over sovereignty may not just be about borders or platforms. It may be about whether intelligence itself can be decentralized. Section 1. Why states still try to control the internet. To understand why decentralized AI matters, you first have to understand the problem it is reacting to. States still control information online in three basic ways. They block access, they monitor access, or they shut access down altogether. Access Now's hashtag #KeepItOnCoalition says its shutdowns tracker dataset has documented internet shutdowns globally since 2016. And its 2025 annual report shows that shutdowns remain a live tool of state power. That matters because shutdowns are the bluntest form of information control. They do not just target one post or one site, they disrupt communication itself. And even when a full shutdown does not happen, governments can still target the routes people use to get around censorship. The Tor Project Support documentation explains that Tor users in censored regions often rely on bridges to get around blocking, and the Tor Project introduced WebTunnel in 2024 specifically as a new type of bridge for heavily censored regions. So the baseline reality is this: governments still have powerful tools. That is why the decentralization story matters. Not because control has disappeared, but because the old control model is becoming less complete. Section 2. The first breakthrough. Open models you can run yourself. For years, advanced AI mostly lived inside large, centralized companies. If you wanted frontier capabilities, you usually had to go through their servers, their interfaces, their safety layers, and their terms of service. If the model is only available through a single hosted service, then access can be filtered, geofenced, throttled, or removed. Open weight models change that. Meta says Llama has been downloaded more than 1.2 billion times, and its OpenAI pages position Llama as openly available foundation model infrastructure. Mistral's model pages explicitly offer open weight models under Apache 2.0, and Hugging Face says its hub now hosts more than 2 million models, 500,000 datasets, and 1 million demos. That is a major structural shift. Because once a model is downloadable and runnable outside one company's servers, AI becomes harder to centrally gate. A government can still block a website, but blocking a model that is mirrored across laptops, repositories, and open communities is a different problem. It is the difference between banning access to one library building and trying to ban every photocopy of every book. And this is where the phrase decentralized AI nodes starts to become real. A node does not have to be a giant data center. It can be a workstation, a home server, an edge device, or a laptop running local inference. If the model can move, then the intelligence moves with it. That is why this is disruptive. It makes AI portable. And portable intelligence is much harder to fence in than hosted intelligence. Section 3. The second breakthrough, peer-to-peer tools that keep information moving. Now let's move from the model to the network. A model is useful only if people can still communicate, exchange files, and route around pressure points. That is where peer-to-peer systems matter. Briar is one of the clearest real-world examples. The Briar Project says its messenger is designed for activists, journalists, and anyone who needs communication that stays available even without normal internet access. Page says Briar does not rely on a central server, can sync directly between users' devices, and if the internet is down, it can sync through Bluetooth, Wi-Fi, or even memory cards. That is not an AI product, but it is crucial infrastructure for a decentralized AI future. Because if information sharing tools can continue working when centralized systems fail, then models, prompts, documents, guides, and generated content can also move through those same resilient pathways. Tor does not remove the internet. It helps users route through it more privately and, where possible, around censorship. The Tor Project Support site specifically documents circumvention using bridges, and its WebTunnel announcement said the feature was designed to help users in heavily censored regions connect to the Tor network. Then there is IPFS. IPFS documentation describes the system as open protocols for addressing, routing, and transferring data using content addressing and peer-to-peer networking. To a real example. When Turkey blocked Wikipedia, a copy of the site was posted to IPFS to restore visibility. Put those together and you get a powerful pattern. Local models, peer-to-peer transport, and censorship-resistant storage. Not perfect freedom, but fewer single points of failure. Section 4, the third. Breakthrough decentralized AI infrastructure. Now we get to the AI native layer. For a long time, people assumed advanced AI required giant centralized clusters owned by a handful of firms. That is still mostly true at the frontier. But it is no longer the only model. Several projects are now explicitly building a decentralized infrastructure for AI training, inference, and agent communication. Gensen describes itself as the network for machine intelligence and says its protocol unifies computing power into an open network for machine learning, coordinating workloads across devices from personal computers to data centers. Prime Intellect is pursuing a similar direction from another angle. Its site describes an open superintelligence stack for training, evaluating, and deploying agentic models. In 2024, it announced Intellect 1, which it described as the first globally distributed training run of a 10 billion parameter model, inviting anyone to contribute compute. In 2025, it announced Intellect 2, described as the first 32B decentralized reinforcement learning training run with permissionless compute contribution. And then there is BitTensor, which describes itself in one line as internet-scale machine learning. These systems do not prove that governments can no longer interfere with AI. What they do prove is that AI infrastructure itself is becoming less centralized. And that matters because the more AI training, inference, and agent communication can be distributed across many participants, the harder it becomes to treat intelligence as something that lives in just a few regulated buildings and a few corporate APIs. In simple terms, if intelligence is spread across a network, controlling it starts to look more like chasing smoke than shutting off a faucet. Section 5. Why this matters for activists, journalists, and civil society. This is where the story becomes practical. If you are an activist, journalist, or dissident community, what do you actually gain from this stack? You gain redundancy. You gain portability. And in some cases, you gain plausible continuity under pressure. Imagine the older model. A centralized social platform is throttled, a hosted AI service is blocked, a cloud storage account is removed, a website is taken down. That is one style of control. Now compare that to a decentralized stack, a local open model for summarizing or translating documents, a peer-to-peer messenger that works without centralized servers, a circumvention layer like Tor bridges or WebTunnel, a content address storage system like IPFS. That does not make repression disappear, but it does change the defender's position. Instead of depending on one platform, one route, and one server, people can combine multiple layers, and each layer makes the next one more resilient. That is why this matters. Because the real breakthrough is not any single tool. It is the stack effect. Open models reduce dependence on centralized AI access. Peer-to-peer messaging reduces dependence on centralized communication. Distributed storage reduces dependence on centralized hosting. Censorship circumvention tools reduce dependence on a single visible route through the network. Decentralized AI infrastructure reduces dependence on a handful of approved compute providers. Once you see the pattern, the political meaning becomes clear. This is not only a technical shift, it is an anti-choke point shift. Now let's be honest about the limits. A lot of commentary in this area becomes mythology. So let's say it plainly. Decentralized AI does not make governments powerless. States can still do a lot. They can cut the network. They can criminalize tools. They can pressure telecoms. They can seize devices. They can infiltrate communities. They can use malware, surveillance, and arrests. And they can block public access to major sites that distribute models and tools. Even the Tor Project's own support discussions show that censorship circumvention remains an active cat-and-mouse struggle, not a solved problem. So the claim here is not that decentralization magically ends control. The claim is narrower and stronger. Decentralization raises the cost of control. It forces censors to attack many layers instead of one. It turns narrative control from a platform policy problem into an infrastructure problem. And infrastructure problems are harder. That is the real intelligence assessment, not freedom wins instantly. But centralized narrative control becomes more expensive, less complete, and less reliable. Digital sovereignty has mostly meant one of two things: either the sovereignty of the state over the network or the sovereignty of the platform over the user. But decentralized AI introduces a third possibility: the sovereignty of the user over their own computational capability. If I can run an open model locally, store content in a distributed system, communicate peer-to-peer, route through censorship circumvention layers, and participate in decentralized compute networks, then the center of gravity shifts. Not completely, but meaningfully. And that may be the deepest reason this matters. Because once intelligence is portable, encrypted, mirrored, and distributed, the question becomes, can the user assemble a stack that survives control? That is a very different internet, and we are already seeing pieces of it in the wild. Conclusion. So let's come back to the opening line. Imagine a world where no government can control what you see or think online. That world is not fully built. Not yet. But the architecture that pushes in that direction is real. Open models are real. Peer-to-peer encrypted communication is real. Censorship-resistant storage is real. Circumvention bridges are real. Decentralized AI training and agent layers are real. And when you connect those pieces, something profound happens. AI stops being just a service you request from a company. It starts becoming a capability that can live in the hands of users, communities, and distributed networks. That does not end censorship, but it does challenge the assumption that control over a few central systems equals control over the narrative. And that is why this story matters. Because the next battle over the internet may not be about content moderation alone. It may be about whether intelligence itself can be made resistant to capture. If that happens, digital sovereignty will not belong only to states, and it will not belong only to platforms. It will belong increasingly to whoever can run the tools, move the data, and keep the network alive.